A particular ecosystem has a balance between two animal species, heffalumps and woozles. The rates of change of the populations of these species are coupled. If the population of heffalumps is represented by x and the population of woozles is represented by y, then dx dt is 0.5x take away 0.2y, and dy dt is 0.1x plus 0.2y. We want to show that this differential equation comes from this information. Okay, so let's start from these two equations. What I'm going to start by doing is differentiating this one with respect to t. And if I do that, I get d2x dt squared is 0.5 dx dt, take away 0.2 dy dt. So d2x dt squared is 0.5 dx dt, take away 0.2, dy dt is 0.1x plus 0.2y. And so that gives me d2x dt squared is 0.5 dx dt, take away 0.02x, take away 0.04y. d2x dt squared then is 0.5 dx dt, take away 0.02x, take away 0.04. Now from here, from this one, I can get 0.2y is 0.5x, take away dx dt. And so y would be 0.5 divided by 0.2x, take away 1 over 0.2 dx dt. So I've got 0.5, let's get rid of the fraction, so it'll be 5 over 2 x, take away 1 divided by 0.2 is 5 dx dt. So d2x dt squared is equal to 0.5 dx dt, take away 0.02x, now 0.04 times 2.5 is 0.1, so I've got take away 0.1x, and then that one there will be 0.2 dx dt. Of course that's a plus because we've got the minus there. And so d2x dt squared is 0.7 dx dt, take away 0.12x, and then bring everything to one side. So take away 0.7 dx dt plus 0.12x is equal to 0, and you'll see that that is this differential equation. So we now want to find the general solution for the number of heffalumps and then the number of woozles. So we want to solve this equation. The auxiliary equation here is m squared take away 0.7m plus 0.12. And so that's m take away 0.3, m take away 0.4. So m is 0.3 or 0.4. 0.4, and therefore x is equal to a e to the 0.3t plus b e to the 0.4t. So that's the general solution for the heffalumps. Now we want y. Now coming back here, 0.2y is equal to 0.5x take away dx dt. Multiplying through by 5 gives me y is equal to 2.5x take away 5 dx dt. So that's going to be 2.5 ae to the 0.3t plus be to the 0.4t. Take away 5. Now we've got to do dx dt, so that's going to be 0.3a e to the 0.3t plus 0.4b e to the 0.4t. So this one here, in terms of the a's, we've got 2.5a there, take away 1.5 there, so that's just going to be an a e to the 0.3t. And then here, we've got 2.5 of those, take away 2 of those, so that's going to be 0.5b e to the 0.4t. We now want to find the particular solution given at the start of the observation there's 20 heffalumps and 15 woozles. So in other words, x is 20. X is 20 when t is 0. So 20 is a plus b. And y is 15 when t is 0. Subtracting there, we get 5 is equal to 0.5b, which means that b is equal to 10. And then from the top one, a must be equal to 10. And so x is going to be 10e to the 0.3t plus 10e to the 0.4t. And y is equal to 10e to the 0.3t plus 5e to the 0.4t. Okay, comment on this solution. Well, both of these are just going to give us continuous growth, and that's unrealistic in any real situation. The populations can't just keep getting bigger and bigger and bigger forever.